Jai Hind everyone. My name is Amrita. I am from CSE department of AKGEC. Today I am going to discuss about a relational database and its integrity constraints. So this is the outline of the lecture. Firstly, we will discuss about the relational data model, how we can store data in the relational data. Fine. And next is the topic of difference between relational database and DBMS. Next is basic terminologies in the relational database. Then we will understand what are the main benefits of the relational database. And then its integrity constraint and types of integrity constraint. So these are the outline of this lecture. Okay, firstly we will understand what is the relational data model. E.F. Codd proposed a relational model to model data in the form of relation or tables. Okay. When we talk about the relational database, what it means we are talking about the tables. So in the case of relational data model, we store the data in the form of tables, okay, which is very easy to access. After designing the conceptual model of the database using ER diagram, after designing the conceptual model of database using ER diagram, we need to convert this ER diagram into conceptual model into relational model that can be implemented by using RDBMS language like Oracle, SQL, MySQL, etc. Okay, so when we create a ER diagram, then we convert it into the tables so that these tables can be easily accessible. The relational model represents how data is stored in the relational databases. A relational database consists of collection of tables, which is assigned a unique name. Now, we will see an example of relational data model. For example, we have a relation or table student, which have attributes roll number, name, address, phone, and age. You can see here. This is the example of a relational data model. Here we are representing our data or storing our data in the form of table. You can see here the name of this table is student. And we have these attributes here. In the ER diagram, we have represent the table student in a form of entity. This entity now converted into the table. And the name of the table is student, and all the attributes will be shown here with columns: roll number, name, address, phone number, and age. So this table is now in the relational data model, where all the data of student is stored. Roll number is stored, name, address, phone number, and age are stored in the database. So this is the form of relational model. Now, the basic terminologies which we use in the relational model. First one is attribute. So, we have already discussed it. These are the attributes of the student. So, it is known as a attribute. Now, next is relational schema. A relational schema defines the structure of the relation and represents the name of the relation with its attributes. For example, in this case, we have the name of the table is student. Okay, and the attributes names are roll number, name, address, and phone number, and age. So this is known as a relational schema. So the name of the table and the name of the attribute combinedly known as a relational schema. Next is the tuple. Each row in the relation is known as a tuple. Fine. You can see here we have 4 tuples here. We have the information about the Ram, we have the information about the Ramesh, Sujit, and Suresh. So we have here 4 tuples. Relational instance. At a time, the entries or records in the table is known as a relational instance, because in this case you can see here we have 4 records in the table: Ram, Ramesh, Sujit, Suresh. So at a particular time, this is the instance of a table. It can be changed if we insert any record in the table, or if we delete any record in the table, then instance will be changed every time. So at a particular time, the overall records in the table is known as an instance of a table. Relational instance, fine. Next is degree. Degree is the number of attributes in the relation is known as a degree of the relation. For example, in the student table, we have 5 attributes. That's why the degree of the table is 5. Next is the cardinality. Cardinality depends on the number of records in the table. If we have 4 records in the table, then cardinality will be 4. If we have 5 records in the table, then cardinality will be 5. Fine. Now the column. Column is the same thing which is known as an attribute also. So column is values of a particular attributes. Now the very important thing is null values. What is the meaning of these null values here? The value which is not known or unavailable is called a null value. For example, you can see in the example here, you can see here in the 4th record of the student table, we have roll number, we have name, we have address, but we don't have any phone number here. So the record is missing here, which is not available here. Then it is known as a null record. So null records are treated very well in the relational database. Next is the relation key. What it means, why we require the relation key. Now you should understand. For example, you can see here we have 4 records, but for uniquely identify a particular record, we need a particular attribute. You can see here the we can uniquely identify with the help of roll number, because the roll number is unique for each and every student. So we should have a particular attribute by which we can identify a tuple. So in this case, we have a uniquely identify attribute is roll number. So this roll number can uniquely identify all others attributes also. So we can find out that by the help of roll number, we can uniquely identify our students, Ram, Ramesh, Sujit or Suresh, because names can be duplicate, but roll number cannot be duplicate here. So there is a condition for the key is that unique and plus not null. So we can say here the attribute roll number, which is a key of your table, should be a uniquely identified and not null. It should not accept null values here. There should not be any student who don't have any roll number. It is not possible here. So primary keys or different type of keys are dependent on the uniquely identification. Now the benefits of the DBMS. What are the benefit of the DBMS and RDBMS? Flexibility. Flexibility means relational database can be flexible, allowing users to rechange or store data. This can help when updating or adding more data to a set. So this is the main advantage of relational database. Accuracy, because the relational database interface is user friendly and easy to navigate. It also can be easy to search for potential errors or inconsistency within a database and correct them immediately. That's why RDBMS is more useful here. Usability. Relational databases are typically straightforward, which can be especially helpful for user who want to simply storage of solution. Next is security. Now what is the meaning of security here? Here we can give access right to the particular users. If my data table is very confidential, so that we can have some access rights for the tables. So data can be secure here. We can tag some table as a confidential and limit to their access, because relation database can be divide the data among tables. So we can have some access rights here in the relational database. This is another benefit of the relational database. We can apply some access rights, or we can secure our database or our tables here. Simplicity. Relational database system have a simple structure. This allows us to operate it using simple SQL queries rather than complex structuring. So that's why it is a very simple to implement these relational database systems. Modifiability, because we can change the database very easily in the RDBMS. Inserting, deleting, updating record is easy because the system holds record in separate tables. Okay, so this can help us efficiently manipulate our data easily. So RDBMS is very beneficial when it comes to the modifiabilities. Next is fault tolerability. Fault tolerance is the ability of the system to continue operating even when one or more its components fail. This can help us to provide security against failure or data losses. Okay, so in the case of RDBMS, we have many different type of benefits. Okay, that's why we use relational database, where we store the data in the form of table. And these tables are very easy to access with the help of different query languages like SQL. We will write a simple query and we can access the data from the tables easily. Or it is very secure also. We can give some security access or access rights also in the table. Now, you can see what is the difference between the DBMS and RDBMS. When we use the term DBMS, when we use the term relational at DBMS. Okay, so DBMS can be the full form of the DBMS is the database management system. And database management system can be a different type. It is not necessary it should be in the form of relation only, or it should be in the form of tables only. But in the case of relational database, always the data is stored in the form of tables. But in the DBMS, data can be stored in the form of files. So for the DBMS, there can be all different type of models like network model, hierarchical model. We have different type of models here. But in the case of RDBMS, data is stored in the form of only table or relation, which is tables are also known as a relation. DBMS is designed to handle small amount of data, but RDBMS is designed to handle a vast amount of data. DBMS provides support only for a single user at a time, but the RDBMS provide multiple access of multiple users. Fine. So these are the main difference between the DBMS and RDBMS terms. Okay. So basically, mainly we use RDBMS when we require a structured database. Fine. Now the next is a important topic is integrity constraint. Now we have to apply some rules on our data. When we create a particular database, then we will create some tables for the database. Then we apply some integrity constraint or some rules in the database, so that this rule can maintain the quality of the information. Or you can say we can insert the valid data into the tables. Okay, any invalid data should not be input into the table. Integrity constraint in database management system are set of rules that are applied on the table columns or relationships for the overall validity, integrity and consistency. Fine. Integrity constraint ensures that data insertion, updation and other processes have to be performed in such a way that data integrity is not suffer, okay, or not affected. Thus, integrity constraint is used to guard against accidental damage also. If the data is damaged or there is some problem in the data, accidental damage is there, then this integrity constraint is used as a guard for the database. Okay. Now, these all are the different types of integrity constraint. First one is the domain constraint, second entity constraint, and next one is the referential integrity constraint, which is very important, and main term of the database, and second is the fourth is the key constraint, the next is the check, and next is not null. These all are the different types of integrity constraint which we can apply on the table, so that database can be secure, or only right data can be inserted into the database or tables. First is the domain constraint. Domain constraint can be defined as a definition of valid set of values or an attribute for it. So, for example, the term domain, what it means? The range of the values. So, for each and every attribute, there should be a range of the value which is valid for that particular attribute. If the value is not in the range of the attribute, or not in the domain of the attribute, then it is not valid value. Okay, the domain integrity constraint contains a certain set of rules or condition to restrict the kind of attribute or values a column can hold the database table. The data type of the domain can be string, integer, character, etc. So we will understand this with the help of one example. Okay, what is the meaning of domain constraint? You can see here, this is a table student again, where we have ID, name, semester and age. When we talked about the IDs, you can see here the values. This is in the numeric form only. So we can have only integer values or numeric values here. So this is the range or domain of the student ID. It should be in the number. Fine. It's in this way, similar way, name can be in the character form only. Semester can be a number form, and again age can be in the number form, because the domain of the age is only numbers, the number form. If we insert the value in the character form, you can see in the example, in the fifth row, we can see here age is inserted as A, which is not a valid value for the age. A is not a age. How can we insert a value in the age? It should be a numeric value here. That's why this is not allowed in the database. This is known as a domain constraint, because this is not in the domain of the age attribute. Domain of the age is only numeric values. And if we are not inserting the particular numeric value in the table, then it is not allowed in the table. So this is known as a domain constraint. It will give you an error if you insert a invalid value in the table. It will stop you to inserting this type of values. This is known as a domain constraint. So it will insert only the valid values in the attributes. Now next is the entity integrity constraint. Entity integrity constraint is used to show that primary key cannot be null. Fine, we have already discussed it. Then what is the meaning of key in a table? Key means which can uniquely identify all the tuples of the table. And there is two conditions for the primary key. First is unique, it should be unique values, and second one is not null values. There should not be insert any null value here. So it should be ensured by the help of entity integrity constraint. You can see in the example, you can see here, if we have a table employee here, and employee ID, employee name, employee salary are the main attributes here, or employee ID is the primary key. So there is not a possibility that we have null value in the employee ID, because each and every employee will have a particular employee ID. Otherwise, this entry cannot be inserted in the employee table. So this is not possible for a particular primary key. Null values are not allowed in the primary key. So this is the integrity constraint. So it will not insert values if it will not have any employee ID. So this is not a valid value. Not allowed as a primary key, can't contain a null value. So every time primary key will have a value, it should not have a null value. This is known as an entity integrity constraint. Next important thing is referential integrity constraint. When we talk about a referential integrity constraint, what it means, we are talking about the foreign key here. Foreign key means when we have multiple tables, then we have to relate these tables to each other. For example, if we have two tables, we can see in the example, if we have two tables, first table is employee and another table is department. So these tables, when we require a data from the one table only, then it is okay. We can find out, we can write a query and we can find out the data from the table, one table. But when we have more than one table and when we require data from the more than one tables, then we have to write a particular query where we have to relate these tables. So for relating the tables, we need a foreign key here. You can see here in the case of employee, primary key is employee name, and in the case, department table, department name number is the primary key for the department table. Now, this department number, which is the primary key of department, will be a foreign key for the employee table. So now these two tables are related. We have a common attribute in these two tables. For extracting the data from the multiple table, we need a join operation in the different tables, and to join operation, we need a common attribute between the tables. So in this case, if you see here, employee table and department table have a common attribute which is known as a department number, and department number is primary key of the department table and foreign key for the employee table. By the help of this foreign key, we will join the table and we can extract the data from the both tables. We can find out the data, name of the employee and department of the employee. Okay, so we can join multiple tables in this way. And what the referential integrity constraints say? Referential integrity constraints say that the values of the primary key department number will be same here and here. Or you can see here, 18 is a value which is not matching here in this table and this table. So this type of values are not allowed here because it is not present in the department. If we don't have any department number 18 here, so how can we give assign John to the department number 18? This is not valid. So this value should be in the department table firstly, then it can be in the employee table, because this attribute is a foreign key in the employee table. Okay, so we can say that this department number is not allowed here. So these values can be match or can be null here. This is known as a referential integrity constraint here, which is very, very important. Now next is the key constraint. Key are the set of entities that are used to identify an entity within its entity set uniquely. So this is already we have discussed about the keys. Keys are those attributes which can uniquely identify, and the value of these attributes cannot be null. So these are known as keys, but we have different type of keys here. We can have candidate key, we can have super key, we can have primary key also. Super keys are the set of the all keys, all possible keys in the tables, and candidate keys are the minimal subset of the key, minimal subset, which cannot be again decomposed. And primary keys are those keys which is selected by a database administrator. Fine. So this is known as a key constraint. So every table will have a particular key which is known as a primary key, and primary can have only unique and not null values in the relational database. You can see here. You can see here, this is the particular table where we have ID is your primary key, but you can see here we again repeating this value. क्योंकि because we have more than we cannot have multiple or duplicate values here. It should be a unique value here, so that this value is not allowed here. Every time primary key will have unique value and it should not be not null. This is a key constraint. It should not be repeated form. Next, there are some checks we can implement or impose on the database. This constraint defines a business rule on a column. All the rows in that column must satisfy this rule. For example, if we have phone number attribute, we can impose a check constraint here. It should be a minimum 10-digit number. If any user input a 8-digit number, then it will give a invalid number error, because minimum numbers can be 10 digits in a particular phone number. So this is a kind of a check in the database. Fine. Limits the data values of variables to a specific set, range or list of values. The constraint can be applied for single column or group of columns. Next is the not null. Next one is the not null. This constraint ensures all rows in the table contains the definite value for the column which is specified as not null. Okay, so not null is again a integrity constraint which we can apply a not null integrity constraint to any of the column. Not in the primary key is already defined. It should not be not null. It should be not null. But in other attributes also we can apply not null integrity constraint. So that if we apply not null integrity constraint, what it means, we cannot left null values in this column. Okay, so these all are the integrity constraint. Thank you.